Okay, great. Just for a moment, we will switch to a different topic, something that is not edible. But then don't worry, we're coming back to beer just after, or wine actually. So we just changed to something not edible and come back to wine after. So our next speaker is Anika Lokker, who is from the University of Liège.
Thank you for your introduction. Well, I will present my poster, which is entitled Non-Destructive Identification of Prehistoric Adhesive with GC-GC-TOFMS. Well, as Caitlin already said, it's different than before because it's about prehistoric adhesives. So, what are prehistoric adhesives? Well, prehistoric adhesives are adhesives which are used to glue a stone to a handle. It can be done with bindings, with adhesives, or a combination of both, as seen in this picture, where an experimental knife is hefted with birch-tar leather bindings onto a wooden handle. When this technique is called hefting, so we call this a hefted knife. Well, some numbers. The first evidence of hefting occurs around 250,000 years before present without glue, and around 80,000 years before present with glue. The evidence is more or less simultaneously found in Africa and Eurasia. So that will mean we will talk about early modern humans in Africa and Neanderthals in Europe. The reason why hefting is so important is because it uses proxy for human cognitive development, as it requires abstract thinking. You have to, before you are starting the napping of your stone tool, you have to think if you want to heft it or not, in order that it will decide which shape you will nap your stone tool. There are already several adhesives identified, for example, pine resin or pine tar, birch tar, and animal glues. And every adhesive has already different properties. For example, pine resin is not waterproof. So if it's raining a lot, you cannot use pine resin, but you can use birch tar because that is waterproof. Sometimes they even add additives like ochre and beeswax to enhance the adhesive properties. So, but what is found in the ground? Because the handles are made of organic material like bone, antler, or wood. So that will be gone after thousands of years. But the stone tools are preserved, and often they have like a tiny bit of residue left. And if they have residue, they often say that might be a hefted stone tool. But in order to be pretty sure if it's hefted or not, the residue has to be identified as an adhesive. And that's the main problem currently, as the current way of detecting or identifying a residue is with chemical extraction, of solvent extraction, followed by a derivatization step, and then injected onto a GCMS system. And then they apply the biomarker method, which means that, for example, for pine resin, they have identified 4 or 5 biomarkers. And if they are found in the residue analyzed, they say, it's probably pine resin. But with solvent extractions, you all know you lose your sample. And in archaeological terms, there is not much sample left. And often all your residue will be extracted. And that's detrimental. So hardly any stone tools are currently chemically identified. They are used microscopically identification. They say, it's probably hefted. But we don't know. Therefore, we want to try and develop a minimal invasive technique. Because adhesives or resins has quite a bit of smell, we will want to try the volatile fraction. It's already done in the past with SPME in both combination of a GCMS system and a GC-GC system. But as everyone knows, SPME is not the most sensitive headspace technique. Therefore, we wanted to try dynamic headspace. Well, a quick run through what is dynamic headspace. I will make a pointer. So we have your sample, which you incubate at a certain temperature during a certain time. After the incubation time, 2 needles are first into the vial. One needle, you have a constant flow of helium at a certain flow rate, which pushes out the headspace analytes onto a heated needle onto a sorbent. The sorbent we currently use is in T-next-TA, and the trap temperature is 20 degrees below the incubation temperature. Well, after a certain volume of gas has passed through the headspace, the extraction is stopped, and then the sorbent is moved to a thermal disruption unit. and then the analyzed are released onto a cool injection system and injected into the first dimensional column. Well, as those parameters are all related to each other and are quite a lot, we use a full factorial design on those 4 parameters to optimize our dynamic headspace extraction method. The center points were measured in triplicate, and it resulted in a total of 19 runs. We used pine resin to optimize our method. It's also tested on hide glue, as animal glues are notoriously difficult to measure with headspace techniques. Moreover, the optimized method of dynamic headspace is also compared to an SPME method on both a modern pine resin and an archaeological sample of around 15,000 years old. So for the full factorial design, I selected 4 groups which are present in pine resin, which are the monoterpenoids, the monoterpenoids oxygenated, the sesquiterpenoids, and oxygenated sesquiterpenoids. Sorry. Well, as you can see, we had to make a compromise with optimal parameters. In the end, we decided to use those parameters. For the temperature, the oxygenated compounds might have benefits from higher temperatures, but as we want to preserve the residue on the stone too, and resins are known to melt around 60 to 70 degrees, we cannot really go higher than 50. So we had to cut that at 50 degrees. And this is how the chromatography looks like. For the pine resin, you see the nice separation of the 4 different groups through the 2-dimensional space. As already said earlier, hide glue is very difficult to measure with Headspace, so we don't see that much. But we do see a series of aldehydes and ketones and a series of linear alkanes. The comparison of SPME versus Headspace, well, the related standard deviation is around 10 to 20% per class, which is accepted for Headspace techniques. But the main difference we found out when we tried to analyze an archaeological sample with both techniques. Whereas the SPME shows generally a blank, and then Headspace was able to detect some analytes, which are seen here and here. Well, to conclude my talk, we tried to optimize in the Headspace GC-GC-TOFMS method with a full factorial design. And with the Headspace, it was possible to detect the volatile fraction of an archaeological artifact, which was not possible with the SPME. Thank you for your attention, and please come see my poster at P1. With questions?
Any questions?
Thank you for the presentation. Just one question. Statement which type of SPME?
No, I didn't say it in my poster, but I used the DP carbons PREHISTORIC. Welcome. One more question.
Okay, if not, we can thank Anika again. Mike?
Okay, and finally, the last speaker for this session is Anika Lokker, who's from the University of Messina, and we move back to some nice beverages, looking at Marsala wines.
Good morning. Thank you for the introduction. First of all, I would like to thank the organizing committee to give me the opportunity to share my research. The first part of the presentation will be focused on the use of this type of flow modulator, then I give you more information about Marsala wine and lactose and their importance in food and beverage aroma. Finally, moving on the development of the method used and the summary results. From an analytical point of view, we employed a commercial flow modulator that is developed by Veerle et al., and it is based on the use of switching valve. This type of modulator offers different benefits, for example, the direct definition with mass and the low auxiliary column flow, but it is allowed to the second modulator. The study of wine aroma is important in quality control and assurance. In fact, the presence or the absence of different key aroma compounds play an important role to the commercialization of the final product. Among volatile compounds, lactones are fundamental constituents of food and beverage aroma, and they contribute to the aroma of the food, including grapes and wine. Most of all are chiral, thus can exist in two enantiomer forms, and the natural abundance is their form. Considering their chiral nature, we decided to employ a chiral column and first dimension to separate the enantiomers. Finally, these lactones are considered a marker of alcoholic beverage aging in wood for the beverage aging in wood barrels and aroma adulteration. For example, whiskey lactones that are present in the slide are considered a marker of alcoholic beverage aging in oak wood barrels. For example, contribute to the aroma of all product aging in its contact. For this reason, we decided to discover chiral lactones in Marsala. Marsala is a dessert wine that can be divided in 5 groups considering the aging time and 3 groups considering the different grapes employed. For the limit question, I will show you only 3 samples that we analyzed. In this slide, I report the experimental condition. In first dimension is present a chiral column, while in second dimension we employed a polyethylene glycol column. The modulation period was set at 4 seconds and the flow pulse was set at 80 milliseconds. A further step, an important step to develop a green method is the use of hydrogen as carrier gas. In fact, it offers different benefits over helium in terms of cost savings and availability. We create the hydrogen in laboratory using the generators, reducing environmental impact. Regarding the sample preparation, we used the HS-SPME with triphasic fiber and 3-octanol as the internal standard. For each analysis, we collected 3 different replicates. It is the chromatograms of a mixture of chiral lactones plus the standard that we analyzed and then discovered the different samples of Marsala. Thanks to the column configuration, we separate all the enantiomer pairs of the chiral lactones, and it is important to note that when present the delta, the gamma series of lactones, the delta series are present in the upper part of the chromatograms, while the gamma series is present in the bottom part of the chromatograms. Finally, the delta hexalactone is a chiral lactone, but in this case we have a single enantiomer because we don't have the racemic mixture to inject in the system. Quantification of chiral lactones was carried out with the multiple addiction at 5 different concentration levels, considering the initial concentration of chiral lactones in the different samples. Considering this different concentration range, we decided to calculate limit of detection, but also the instrument detection limits to consider the real concentration that arrive in the mass. In fact, with the use of this type of modulator, the quantity of the amount of the samples that arrive in the mass is lower than the one present in the column. But in this case, the limit of detection and the instrument detection limit values are in agreement. The ideal values ranged from 0.0 for the first enantiomer of gamma-valeractone and delta decalactone, both isomers of delta decalactone and dodecalactone and whiskey lactone cheese, to 0.17 for the only enantiomer of delta hexalactone. In this case, I report for limit question all three samples that we analyzed. The complexity of the space of Marsala appears evident with overall 400 peaks detected. For this reason, the use of a bidimensional approach is fundamental to discover chiral lactones among the aromatic profile. But now we started to evaluate and characterize the all volatile fraction of the different samples. In this slide, I show the quantification of the lactones that we discover in different samples. And it appears that the whiskey lactones have the highest concentration among the other lactones, confirming that the Marsala have been aged in oakwood barrels. It's important to note that in all cases are present the first enantiomer of both isomers of the whiskey lactones because are naturally present in oakwood, while the other two isomers are formed during the chemical composition and synthesis of the compound. In the three cheapest wine, the first, the second, and this one, the whiskey lactones are under the limit of detection values that we calculated. Among the other lactones are present in lowest concentration, but it is confirmed by a previous studies present in literature. In conclusion, chiral analysis can provide valuable information about food safety and authenticity in order to detect possible adulteration. This study developed an effective and targeted method for simultaneous determination of 15 chiral lactones in Marsala wine, and the complexity of the samples justified the use of a bidimensional approach. Thanks to you for kind attention.